Okay. Today we are going to do with the application of the ATS or the PMO theory to the sigmatropic rearrangements. Now, when we are talking about the sigmatropic rearrangements, we are going to do with the hydrogen migration. It's a migration of the sigma bond to the allylic system. So we are going to do with the hydrogen migration as well as the group migration. Now, in case of the group migration, for the FMO theory, you all have seen two conditions. Group migration with retention of configuration, and you have seen with inversion of configuration. With retention and inversion of configuration. Now, in this one, we are going to do with the 4n pi system. Before going to the 4n pi system, again the ATS and the PMO theory, as we have done it in the case of the cycloadditions and the electrocyclization, we need to consider the basic set of molecular orbitals, that is nothing but the psi functions, psi1 functions. Okay, so we will be doing with the 4n pi system. Under the 4n pi system, we have 1,3 migration. Now, this 1,3 migration can be a hydrogen. First, we'll do with the hydrogen migration. Check for the number of nodes in the transition state. Now, in the previous video, we have seen that we are going to divide the transition state based upon the number of nodes. Now, if you are having an odd number of nodes, then it belongs to a Mobius transition state. And if it is having an even number of nodes in the transition state, then it belongs to a Huckel's aromatic transition state. Sorry, Huckel's transition state. When the molecule belongs to a 4n pi system, it is a Mobius aromatic, if not an anti-aromatic. If it's a 4n pi system under the Huckel transition state, it is Huckel anti-aromatic, otherwise aromatic. All aromatic transition states are considered to be thermally allowed. Okay, and all anti-aromatic are considered to be photochemically allowed. Aromatic are thermal, anti-aromatic are photochemical. Okay, now 4n pi system. This is your pi system. Hydrogen group migration. If this is in the transition state, you have it as a hydrogen free radical and an allylic free radical. Hydrogen migration. Okay, take it to a basic set. Basic set is your psi1 function. Psi1 function does not have any node. Okay, in the transition state, you will be getting a free radical. So I'm going to put the basic set as it is, plus hydrogen. Now we have two modes of interaction in the case of the hydrogen migration. We have a suprafacial interaction and we have an anterafacial interaction. Okay, so we are going to do first with the suprafacial interaction. So when you are doing with the suprafacial interaction, on the same side, write the psi1 function as it is. Okay, this is plus, plus, minus. I'm getting a bonding interaction. So since it is a bonding interaction, I have 0 nodes. It's an even number. Huckel transition state. Because it belongs to a 4n pi system, it is anti-aromatic. As it is anti-aromatic, it is considered to be photochemically allowed. Okay. Now, take the same for the anterofacial interaction. When you're going to take it for the anterofacial interaction, basic set, that is the psi1 function, anterofacial, your hydrogen is here, opposite side, you get a presence of one node. So one node, it is an odd number of nodes, it is a Mobius transition state. Since it is a 4n pi system, it is aromatic. All aromatic transition states are thermally allowed. So for a 1,3 migration, in case of 1,3 migration, hydrogen migration, suprafacial migration is photochemically allowed, whereas anterofacial migration is considered to be thermally allowed. We are going to do with the next one is a group migration. Okay, sigmatropic rearrangement, group migration, we are going to do with both retention and inversion of configuration. Okay. One three group migration. Basic set psi1, in the transition state, break the connectivity between the group as well as the pi system. B. Now, I'm going to do a suprafacial migration with retention of configuration. When I'm going to do a retention of configuration, I'm going to put the p orbital as it is. Okay. Now, basic set this is the group which has been migrated. It's considered to be a chiral group. I am having 0 nodes, even number, belongs to a Huckel transition state. Okay. Since it is a 4n pi system, why it is a 4n pi system? 1 3 when I am going to add, I am going to get the even number 4. 4 is a factor of your 4. So it is said to be divisible by 4 without any remainder. So it belongs to a 4n pi system. Okay, it's a 4n pi system. So this Huckel transition state is considered to be anti-aromatic. As it is an anti-aromatic transition state, it should be photochemically allowed. Okay, next. Take suprafacial migration with inversion of configuration. Okay, when you're going to do a suprafacial migration with inversion of configuration, write down the psi function as it is, basic set, right? Plus minus. Now, rotate the p orbital by a 90-degree turn. Plus minus. This is your orbital, right? Suprafacial migration, I am going to get one node. So one node, which is considered to be odd, It is a Mobius transition state. Because it belongs to a 4 and pi system, it is an aromatic transition state. Since it is aromatic, it is considered to be thermally allowed. Okay. So 1,3 group migration, suprafacial with retention of configuration is photochemically allowed, whereas suprafacial with inversion of configuration is thermally allowed. Now I'm going to do the same thing for anterafacial migration, both with retention and inversion of configuration. The same molecule in the transition state, anterafacial migration with retention of configuration. In the retention of configuration, I'm going to draw the p orbitals. B, anterafacial migration, I'm getting one node. So presence of one node, this is considered to be odd. Since it's an odd number of node, it is a Mobius transition state. It's a Mobius transition state, and Mobius transition state for a 4 and pi system is considered to be aromatic. All aromatic transition states are considered to be thermally allowed. Okay. Now go for the anterafacial migration. With inversion of configuration. When you're going to do an inversion of configuration, you just rotate the group by a 90-degree turn. A, your chiral molecule, plus minus anterafacial migration with inversion of configuration. I'm getting 0 nodes. It is Huckel transition state. Sorry, it's a Huckel transition state. Because the molecule belongs to a 4 and pi system, it is anti-aromatic. As it is anti-aromatic, it is said to be photochemically. So 1,3 group migration, anterafacial with retention of configuration is thermally allowed, whereas with inversion of configuration, it is photochemically allowed. We will be writing all these again in the selection rules. Now, we will be now studying about the 4n plus 2 pi system, that is nothing but a 1,5 migration. Okay. Now, in this 1,5 migration, similar to the 1,3 migration, we will be doing with the hydrogen migration as well as with the group migration. Now, when we are considering the hydrogen as well as the group migration, 4n plus 2 pi system, it is 1,5 migration. We'll do with the first one, that is 1,5 hydrogen migration. Okay, 1,5 hydrogen migration. In this 1,5 hydrogen migration, pentadienyl system. For the pentadienyl system, again you go for the basic set, that is the Psi1. Hydrogen attached to it. In the transition state, you get a pentadienyl radical. I'm writing only the termini because the termini ones are said to be getting attached to the group which is going to migrate. Suprafacial migration. Okay, So when you're going to do a suprafacial migration, check in the transition state. Are you going to get a node or you're going to get a bonding interaction or an anti-bonding interaction? If you're getting a bonding interaction, then it is a zero node. If you're getting an anti-bonding interaction, check for how many anti-bonding interactions you're having. So here I'm going to have a bonding interaction. So it's a bonding interaction. I have zero nodes. Zero nodes are nothing but your even number of nodes. Since it is even number, it belongs to a Huckel transition state. Huckel transition state. As the molecule belongs to a 4n plus 2 pi system, Huckel transition state is considered to be aromatic transition state. Now, as it is aromatic, it is considered to be thermally loud. Now, take the same molecule for the antarafacial migration. In case of antarafacial migration, you're going to take the pentadienyl with the basic set, hydrogen moiety, hydrogen atom is going to, group is going to migrate. I am getting a node. So one node is going to exist. Okay. So one node, it is odd number, odd nodes, odd number of nodes in the transition state. So it is a Mobius transition state. Okay. It's a Mobius transition state. Because it belongs to a 4n plus 2 pi system, it is anti-aromatic. Anti-aromatic. All anti-aromatic are considered to be photochemically. Okay. I hope is it clear. 1,5 hydrogen migration, suprafacial migration involves zero or even number of nodes. It is a Huckel transition state, since the molecule belongs to a 4n plus 2 pi system, it is an aromatic transition state, hence thermally allowed. Now, this for the same moiety, if I'm going to check for the antarafacial migration of hydrogen, I get one node. Since I'm getting an odd number of nodes in the transition state, we can say that the transition state belongs to a Mobius transition state. As the molecule is a 4n plus 2 pi system, it is anti-aromatic. All anti-aromatic transition states are photochemically allowed. Now we are going to do the same one, 4n plus 2 pi system, but with group migration. Again, group migration with retention of configuration and with inversion of configuration. So 1,5 group migration. The group what you are going to attach is a chiral group. Because you are attaching a chiral group, you should be having all the groups which are attached to the carbon to be different. Take for the basic set. Okay. In your transition state, I have a pentadienyl radical. And I have the group to be existing as a group radical. B, D, A, right? Now, we'll go with the suprafacial migration. With retention of configuration. That means as it is the group you are going to attach it. So when you are going to attach the group as it is, check whether you are going to get a bonding interaction or whether you're going to get an anti-bonding interaction. If you're going to get a bonding interaction, then it indicates the presence of zero nodes. Okay. If you're going to get an anti-bonding interaction, it indicates the presence of a node. Now here I am going to get a bonding interaction. Since it is a bonding interaction, I will be having zero nodes. It's an even number. Since it is even, it is a Huckel transition state, as a molecule belongs to a 4n plus 2 pi system, it is an aromatic Huckel transition state. As it is an aromatic Huckel transition state, it is considered to be thermally. Okay. Now, take the suprafacial migration with inversion of configuration. Now, when you're going to do with the inversion of configuration, rotate the molecule by a 90-degree turn. Again, take the basic set for the pentadienyl system. Rotate the molecule by a 90-degree turn. It's a chiral molecule. I'm getting one node. So one node is going to exist in the transition state, odd number of nodes. Since it is odd, it is a Mobius transition state. A Mobius transition state molecule belongs to a 4n plus 2 pi system. It is anti-aromatic. All anti-aromatic transition states are photochemically allowed. Okay, so group migration with suprafacial with retention of configuration involves 0 nodes in the transition state. Because it is an even number, it belongs to a Huckel transition state. It can be classified as a Huckel transition state. Molecule belongs to a 4n plus 2 pi system. So it is aromatic. All aromatic transition states are thermally allowed. Now, come to the suprafacial migration with inversion of configuration for the group. When you're going to do the inversion, you just rotate the group by a 90-degree turn in the transition state. When you are going to add it suprafacially, you are going to get one node in the transition state. Since it is odd number in the transition state, I can classify the transition state as a Mobius transition state. A Mobius transition state is considered to be anti-aromatic, hence it is photochemically allowed. Now, we are going to do with the 1,5 group migration, antarafacial with retention of configuration and antarafacial with inversion of configuration. I'm going to put the molecule as it is. So, antarafacial migration with retention of configuration. In the transition state, check for the basic set plus minus it's a chiral molecule. I'm getting one node. So presence of one node, it's odd number. It's a Mobius transition state. Since it is a Mobius transition state, molecule belongs to a 4n plus 2 pi system. It is anti-aromatic. All anti-aromatic transition states are photochemically allowed. Now, go for the group migration antarafacially with inversion of configuration. Inversion of configuration, rotate the molecule by a 90-degree turn. It's a chiral molecule. Below the plane, above the plane. Okay. Antarafacial migration. I have 0 nodes. That is even number of nodes. Hence, I can classify it as a Huckel transition state. Since it is a Huckel transition state, molecule belongs to a 4n plus 2 pi system, hence aromatic. All aromatic transition states are thermally allowed. Now we are going to make use of this. Now we have done with the ATS theory. I'm going to write the selection rules for this sigmatropic reaction for the 4n plus 4n pi system as well as for the 4n plus 2 pi system. Make a tabular column so that it will be easy for you all to remember. And when you all are writing it for the essay, you will be able to remember it well and write it correctly. Selection rules for the sigmatropic reaction. Serial number 4n pi system, sorry, type of pi system, whether it is hydrogen or group migration, configuration, number of nodes in the transition state, type of transition state, and whether it is considered to be allowed or forbidden. First one, 4n pi system. It's a 1-3 migration. Hydrogen migration, you don't have any configuration. I'm going to write it below itself. Suprafacial migration. Hydrogen suprafacial migration. In this one, the number of nodes what I have got is 0 nodes. That is even. Belongs to a Huckel anti-aromatic. Why anti-aromatic? Because it is a 4n pi system. Photochemically allowed. Hydrogen antarafacial migration. No configuration. I have one node, odd number, Mobius, aromatic transition state, thermally allowed. Next, group migration, suprafacial. Configuration, retention of configuration, 0 nodes, even number. It's a Huckel anti-aromatic, photochemically allowed. Group migration, suprafacial migration with inversion of configuration, odd number of, sorry, one node, so odd number. It is a Mobius aromatic transition state, hence thermally allowed. Again, group migration, antarafacial with retention of configuration, one node, odd number of nodes. It is a Mobius aromatic transition state, allowed thermally. Group migration, antarafacial with inversion of configuration, 0 nodes, even number, Huckel anti-aromatic, photochemically allowed. Foreign pi system, hydrogen suprafacial migration, 0 nodes, Huckel anti-aromatic transition state, hence allowed photochemical. Huckel hydrogen antarafacial migration involves one node, that is odd number of nodes. It is a Mobius aromatic transition state, hence thermally allowed. Suprafacial group migration with retention of configuration, 0 nodes again. It's a Huckel anti-aromatic, photochemically allowed. Group migration suprafacially with inversion of configuration, presence of one node. It's a Mobius aromatic transition state, thermally allowed. Group migration antarafacially with retention of configuration involves one node, that is odd number. It's a Mobius aromatic transition state, hence thermally allowed. It's a group migration antarafacially with inversion of configuration, involves 0 nodes. It is a Huckel anti-aromatic transition state, hence photochemically allowed. Now I'm going to go for a 4n plus 2 pi system. Okay, so second one, 4n plus 2 pi system. It's a 1,5 migration, hydrogen migration suprafacially, no configuration. This is presence of 0 nodes, that is even number. It's a Huckel aromatic transition state, so it is thermally allowed. Hydrogen antarafacial migration, no change in the configuration, 1, that is odd number of nodes. It is a Mobius anti-aromatic, hence photochemically allowed. Group migration suprafacially with retention of configuration, 0 nodes. It is a Huckel aromatic transition state, hence thermally allowed. Group migration suprafacially with inversion of configuration, 1 node, that is odd number of nodes. It's a Mobius anti-aromatic, photochemically allowed. Group migration antarafacial with retention of configuration, 0 nodes. Huckel, antarafacial with retention of configuration, 1, that is odd number of nodes. It is Mobius anti-aromatic, photochemically allowed. I hope you are able to see. Group migration antarafacially with inversion of configuration, 0 nodes, that is even. It is Huckel aromatic, hence thermally allowed. For a 4n plus 2 pi system, which is a 1,5 migration, hydrogen suprafacial migration will have 0 nodes in the transition state. It is a Huckel aromatic transition state, hence thermally allowed. Hydrogen antarafacial migration involves 1 node, that is odd number of nodes. It is classified as a Mobius anti-aromatic, hence photochemically allowed. Group migration suprafacially with retention of configuration involves 0 nodes in the transition state, hence classified as a Huckel aromatic transition state, hence thermally allowed. Group migration suprafacially with inversion of configuration involves odd number of nodes. It is a Mobius anti-aromatic transition state, hence photochemically allowed. Group migration antarafacially with retention of configuration involves 1 node, that is odd number of nodes. It is classified as a Mobius anti-aromatic transition state, hence photochemically allowed. Group migration interfacially with inversion of configuration involves zero or even number of nodes. It is a Huckel aromatic transition state, hence thermally allowed. Now, all these conditions are based, will be on par with the both with the FMO theory as well as the ATS theory. Now, we have another theory which is going to correlate whether the given set of conditions are said to be possible. Now, that theory is called as a molecular orbital correlation theory, which we'll be doing it in the next video. Or molecular orbital correlation theory is can be applied only for the electrocyclizations and the cycloadditions. Why can't it be applied for the sigmatropic reactions? Is now, as I have told you previously, in the sigmatropic reactions, the number of the sigma and the pi electrons will not change either in the reactant or in the product. That is, the number is said to be same. That is the reason we are not going to apply the correlation theory for the sigmatropic reaction. Whereas in the electrocyclizations or the cycloadditions, there is a change in the number of the sigma as well as the pi bonds. That means at the expense of one pi bond, one new sigma bond, or at the expense of two pi bonds in the, both the reacting partners, two new pi bonds, two new sigma bonds are said to be formed. So because there is a change in the reactant as well as in the product, we are going to use that correlation diagram. Whereas in the case of the sigmatropic reactions, we are not going to use the correlation diagram, which we will be doing it in the next video. I hope you all have understood the ATS theory, which is being applied to the sigmatropic reactions. Thank you.